All right, today we're going to talk about simple compound interest. Simple interest just comes from, it's your principal. Your simple interest is your principal. Let's say you have $100 times your rate. Let's say you're getting 5% per year times, let's do it for 1 year. Principal times rate times time. So your interest would end up being $5, right? Now the account balance, the account balance is the principal plus the interest. And since we know the interest is principal times rate times time, we could actually factor that out and rewrite it like this. So either of those will work. Okay. So let's do some simple interest examples here. Suppose you borrow $10,000 from a friend, agree to pay it with 3% annual simple interest. So it's 3% on the $10,000 every year. 3% just on the original amount. That's simple interest, okay? So, the interest would be putting in $10,000 times the interest rate 3%. So put it in as a decimal. And for each year. So each year you're getting $300. So you started out with $10,000. For that first year you earned $300. You end up with $10,300 at the end of year one, right? And again, simple interest just means you're only getting $300 every year. It stays the same. That's simple interest. It's on the original amount. So it's just going up linearly. $300. See how it goes up $300 by the end of each year? And so you end up with $11,500 after 5 years for this scenario. Let's do 4 examples with some simple interest scenarios. Suppose your city's building a new park, issues bonds to raise the money. You obtain a $5,000 bond that pays 4.5% simple interest. It matures in 5 years. So how much will you have at the end? Well, the amount you have at the end is whatever you had started with, the $5,000 plus the interest, right? So principal is $5,000 plus the interest would be principal times rate times time. So we're ending up with 5,000 plus what's the interest? Well, it's 5,000 at 4.5% for 5 years. So this ends up being 5,000 plus 1125, so we end up with 6125. And you can also plug it into this formula if you guys want to. The amount you have at the end is the 5,000, 1 plus the interest times 5 years for the simple interest. Either of those, 0.045 times 5 is 0.225, so 1 plus that, 1.225. Either of those will give you that. That's how much you end up with at the end. Right, $6,125 because you're getting 4.5% simple interest. So the next one, Maria is investing $16,000 at 3%. Again, simple interest for 19 years. How much interest will she earn? Part A, interest is principal times rate times time. 16,000, 0.03 for 19 years. That just punch that in, 9120. Now, how much will be in the account at the end of the 19-year period? Well, that's your principal plus your interest, right? So you started out with 16,000 that you invested, and you earned 9120 in simple interest. So it looks like we end up with 25,120 at the end. Now Martha here on example 4 decides to invest $4,500 into a savings account, 2.5%. How long will it take the investment to double? So I take my my account that I have is P principal plus interest, or I could use this one as well. They're the same formula. So the amount you have at the end, we want that to double. So if I start with $4,500 as my principal, my interest rate is 0.025. I need to know how long, what's my T for the investment to double, for the amount to double. Well, if I start with 4,500, double that would be 9,000. I want that to double. And then I'm going to go ahead and distribute that. I have 9,000 equals 4,500 times 1. 4,500 times 0.025 is 112.5 T. Let's subtract 4,500. Remember, we're solving for T here. So 4,500 equals 112.5 T. 112.5 T equals 4,500. And then let's go ahead and divide by 112.5. And so my T ends up being 4,500 divided by 112.5. That'll end up giving me 40 years. So I'll take 40 years at 2.5% simple interest to double in value. All right, our last one here. Example 5 here, we've got how much would you need to deposit in an account now? Now. So we're solving for what's our P. All right, what's the principal amount? How much do you need to put in initially in order to have 4,000 bucks? That's what you're going to end up with in your account at the end in 15 years. So T is 15. Assume the account earns 7%. So R is 0.07. Simple interest, right? So we're using simple interest formula. So I say, all right, here's my simple interest formula. Or if you want, you can use principal plus interest, either one, right? Remember, I is P, R, T, but I'm going to go with this one here. The account at the end, I want to have 4,000 at the end. What am I initially putting in? I don't know. I got to solve for that. 1 plus the interest rate is 7%. I want this for 15 years. Now I go 0.07 times 15, that'll give me 1.05. And then 1 plus 1.05 is 2.05, so I have 4,000 equals 2.05 P. I got to solve for P, so let's divide both sides there by 2.05. And so my 4,000 divided by 2.05 ends up being 1951.219512. We're talking about money here, so let's round that to the nearest cent. So I need to put in $1,951.22 to end up with 4,000 bucks after 15 years at a 7% interest, simple interest scenario. Well, this is probably my favorite section because if you want to be rich, this is what all rich people understand. They understand the power or the magic of compound interest because it grows exponentially. You know, so we have simple interest. So let's compare the two. Simple interest, what is that? That's our last section. That's where we have, let's say for example, we had $10,000 in a retirement account. It's earning 10% simple interest, right? 10% of 10,000 is $1,000. So after year one, I start with 10,000, I add in my interest of 1,000, and I end up with 11,000 after year one. And every year, notice it's the same 1,000 bucks, right? So after every year, it's just going up by 1,000 every time, right? 1,000 bucks every time. Simple interest. Clear up here to year 20, I'd have $30,000. If I jump clear to year 40, I'd have $50,000, right? Again, simple interest. So this is growing linearly, right? Simple interest. Let's compare that to where the more reality, right? Whereas you put your money into an investment and you let the interest, you let the interest build on your accumulated balance year to year. Okay, so that's this table. Again, I start out with 10,000 bucks. 10% of that's 1,000, so I add in 1,000. I still end up at the same place after year one, $11,000, right? But now I'm starting with $11,000 and taking 10% of that. Well, 10% of that is $1,100, not just $1,000, right? And so now I have $12,100. I have $100 more than I would have had after year two, right? And it's doing this year to year. And you might be thinking to yourself, well, that's not that big a deal. You know, after year 20, I have 67,000. Well, that's double what you would have had with simple interest. And boy, does it make a difference. If you look at year 40, 20 years later, you have almost $500,000, and you would have only had with linear growth $50,000 with simple interest. So this is the magic of, it's eighth wonder of the world, as they say, or I think Einstein said, this grows exponentially. Compound interest grows exponentially. Big deal. You want to be rich, you got to get your investments to grow year to year exponentially, because after time T, right, especially if you have time on your side, it makes a big difference. Big difference in the end. Especially if you can add to it year to year, not just take the interest, right? So here's a graphing calculator showing you the difference. See this huge gap after 40 years? My goodness, I'd rather be in that compound interest scenario, no question. Well, this process can be generalized with this formula. So we're going to go ahead and play with this formula. That's the compound interest formula. A is still the account balance after time T. P is still the initial amount you put in, the initial investment, the beginning balance. R is still your interest rate. T is still your time in years, but your N is your compoundings per year. So like typically, like maybe a savings account, is going to kick you out a little interest every month, right? That would be a monthly compound, and your N would be 12 in that scenario. If you have a yearly compounded, and your N has to be 1, and so on. So we need to know what our compoundings are per year. So let's go ahead and use that. Let's revisit it and do it with the formula now. Here's our compound interest formula. How much would we have after 40 years if we put $10,000 in? We track the S&P 500 and we get 10%. So our interest rate 0.10 at the end. Now it's compounded annually. So how many times a year? Only once a year. So N would be 1. Annually is the key term there. So N is 1. Wherever there's an N, I put 1. And then for T, how many years did we do this for? We did this for 40 years. Okay. And then we go ahead and use our calculator. 0.1 divided by 1 is 0.1. So I got 1 plus 0.1 is 1.1 to the 40th power. And then I'm going to punch in 1.1 to the 40th power. I get 45.259255557. And then I punch that in, 452,592.56. If you notice, that was the same as what we had with the table. And you can do that. Notice I did it. I worked that from the inside out. With Desmos Scientific, you can punch that in all at once if you choose to, if you'd like to. So let's go ahead and do that with the scientific calculator. So we had 10,000, 1 plus 0.1 divided by 1. Now I do shift 6 or use that, or the caret key right here, or to the exponent key. And I've got 1 as my N. Times T was 40 years. And you notice it'll spit that out right there, 452,592.56. All right, now what I'm going to do is, now that we've used the formula, I want to use what's called a financial calculator to do this same scenario. It's called a time value of money calculator. So if you go ahead and go to fncalculator.com. Financial calculator, you can search that if you want. It's this one right here, fncalculator.com. And if it doesn't take you straight to it, you click on that time value money calculator there, TVM calculator. Now what we're doing is we were, let's see what our scenario is. We were putting $9,000 in an investment, paying 11% compounded monthly. So let's do it with the formula first, and then we'll compare it to the financial calc, doing it with the calculator. I'm putting in $9,000, 11% interest, compounded monthly. How many times a year is that? Monthly would be 12, so 12 is our N. And I'm going to do this for 15 years, so 15. And so this will end up being 9,000. 0.11 divided by 12, that's 0.0916 repeated. So 1.0916 repeated. 12 times 15 is 240. And then 1.0916 repeated to the 240th power. And then I punch that in times 9,000 in the front. Now, again, don't cut this off. Keep your decimals all the way out until the very end so you don't have rounding error on this. So put 9,000 in with those scenarios, we'll end up with 80,415.14. Now with the time value money calculator, you want to keep your mode end, mode on end, and you want to have it on end because it's giving you the interest at the end of that cycle. Okay, so at the end of the month or the end of the year, whatever the compoundings are. The present value, that's what you're starting with. We're starting with $9,000. Now, we are not making any payments at all. I'm going to have to hit this button. I want to know the future value. That's my A. I want to know what that is. My interest rate I'm getting is 11%. Now, this is as a percent, not a decimal, as a percent. So the calculator assumes that assumes that we're too dumb to put that as 0.11. So it's made it where it calculates it as 0.11 for us. Okay, so that's as a percent. Now the periods right here, this is actually N times T. This is N times T. So in this case, we did this 12. It was compounding monthly, N is 12, and we did this for 15 years. So 12 times 15, there's 240 compoundings. And notice I have to have my compoundings here monthly, right? This is monthly, so I got to make sure that compounding says monthly. So let's go ahead and do that with our time value money calculator. I'll click on the future value. Oops, no ads. $9,000. I'm not putting anything in. I'm going to click future value at the very end. Right now, I'm 11%. N times T, 12 times 15, 12 compoundings per year for 15 years is that 240. I got to make sure that that's monthly right there. Now let me click future value. How much do I have to take out? $80,415.14. So notice these signs change, and if I'm going to be picky about it, it's costing me. I really should make that negative. It's costing me. That's money out. Positive would be money in my pocket. $80,000 in my pocket. 415. But notice it'll just change signs. That's indicating money out, money in type of deal. Okay. But I get the same thing, right? So much easier if you can talk yourself through that scenario. We'll use this financial calculator quite a bit. So here's another one, the financial calculator. And we'll go ahead and we'll do it with the, why don't we do it with the formula as well. So a CD, you know, you got to leave it in for a specified length. But suppose we're putting in $6,000. So there's our initial deposit, right? $6,000. It's paying 6%, so 0.06. It's compounded quarterly. 4 times a year would be quarterly. So N is 4. And how many years are we doing this for? 10 years. Okay. So I punch this in. So I got 6,000. I've got 0.06 divided by 4 is 0.015. So plus the 1, 1.05. The 40th. So the 6,000 times 1.8814018409. Multiply that by 6,000. I should end up with 10,884.11. That's how much I'll have at the end of 10 years in this CD. Now let's do it with the time value money calculator. All right, with the time value money calculator, I am compounding quarterly, right? So make sure you got a quarterly down there. I'm starting with $6,000. I'm not making any payments. I'm trying to see how much money I have at the end of 10 years. My interest rate is 6%, not 0.06 there. Again, that's as a percent. So I've just put the 6 in right there. But how many periods is this? This is N times T. It's quarterly for 10 years. So I need to have this compounding 40 times. Compounding 40 times. And then I click it, and it will spit out my 10,884.11. Again, you can ignore the sign there. Or if you want to make the 6,000 negative, that's your money out. It costs you 6,000 to make this investment. You know, if you make that negative, this one will be positive, and so you're getting the cash of 10,884 at the end, right? So you've made some interest, quite a bit of interest, $4,884.11 in interest, right? Because you initially put in $6,000. All right, this time we've got a 529 plan. If you don't know anything about 529 plans, they grow tax-free. It's a way to save for like your child's education or family member or whatever, right? And then all the capital gains, in other words, all the interest, everything that you've earned in that account over that time is tax-free as well. So that's a big deal, right? Not having to pay taxes on it. So Lily here wants to set up a 529 account for her granddaughter. Like the account to grow to $60,000. Okay, $60,000 we want at the end. Let's do a formula first. She wants to end up with $60,000 over 18 years, right? So T is 18. How much does she need to invest now? So P, we're solving for P. What do we need up front? Trying to track the S&P 500, so 10% interest. It's going to compound monthly. N is 12. N is 12. And so we've got to solve this for P. Want to end up with $60,000. What do we need to invest up front? 12 times 18 gives you 216. Again, don't cut off any decimals to the very end. And now we're going to divide both sides by that, 6.004693.038. And that P will end up being 60,000 divided by that. We'll end up with 9,992.18. So it's saying Lily's got to put $9,992.18. If it grows at 10% compounding monthly for 18 years, she'll end up with $60,000, right, to help pay for her granddaughter's college education. Let's do it in the time value money calculator. We don't know what we're trying to put in up front. That's what we're solving for. We're making no payments here, but I want to be able to pull out, give to me $60,000. $60,000. We're going to assume we can track the S&P 500 and get 10% interest. How many periods is this? N times T, 12 compoundings per year for 18 years, 216 periods. And notice I got to be monthly down there for my compounding. I go ahead and click on that present value button on my calculator. Let me reset this. I make sure that's monthly. Solving for that. No payments. I want to have $60,000 for me. At the end, my rate is 10%. Doing this for 216 compounding periods. And I click on present value. Hey, sure enough, our calculation was correct. We have to put in, thus the negative, cash flow out, $9,992.18 in order to have $60,000 for this scenario. Well, thanks so much for watching about simple and compound interest. See you next time.